This is our FSE 360 pump test line. The pump we used was an electric pump located at the Ashland building. The design specs for this pump were 500 GPMs and 1770 RPMs. This is the hose monster attachment tool that we used for the test. The pressure is fed back to this panel where you can read the PSI on the gauge. This is the conversion chart that we used to help transfer the PSI into GPMs. And this is the tachometer we used for the RPMs. All we did for the churn test was turn the pump on and let it warm up for a couple seconds. After that, we're going to get the intake PSI, the discharge PSI, and then the tachometer reading. For the 100% pump test, we only opened up one valve. This is allowing the pump to flow at 100% capacity. As you can see, it's flowing out the end of the hose monster attachment that's giving us a PSI at the hose monster gauge. For this test, we're also still going to get the intake pressure and the discharge pressure and the tachometer reading. This is the hose monster pressure. It's reading about 15 psi, which is equivalent to about 406 GPMs. All we did for the 150% pump test was open up a second valve. This allows the pump to flow at 150% capacity and is now flowing out of the top and bottom part of the hose monster. For this test, we are still getting the intake PSI, the discharge PSI, the tachometer reading, and the hose monster PSI. The hose monster PSI was reading about 30 PSI. 30 PSI is equivalent to 573 GPMs. This is the hose monster graph. It's not going to look like your standard graph because during the churn test, there is no pressure put on the gauge. And as the PSI builds in the hose monster gauge, the GPMs also rise. This is the PSI and GPM flow graph for the actual design of the pump. Now this is the actual graph that we got using the numbers that we got from our test. As you can see, when you compare these two graphs next to each other, the design graph tapers off much slower than the actual.